Close your eyes for a moment and imagine walking through a bustling market somewhere in ancient Eurasia, perhaps 50,000 years ago. The sun is setting, casting long shadows across a landscape that would seem both alien and familiar. You're moving through crowds. But here's the strange part. Not everyone you pass is quite like you. That tall, muscular figure haggling over some stone tools, that's a Neanderthal, with their distinctive brow ridge and barrel chest built for Ice Age winters. The smaller, delicate-featured person examining some shells, they might be a Denisovan, carrying genetic secrets we're only now beginning to uncover. And there in the shadows at the edge of the market, perhaps watching with intelligent, cautious eyes, could that be Homo floresiensis, the so-called hobbit people who stood barely 3 feet tall? This isn't fantasy. For most of our species' existence, we shared this planet with other types of humans. Other species who made tools, controlled fire, buried their dead, and possibly even told stories under the stars just as we do. They weren't our ancestors. They were our cousins, following their own evolutionary paths, living their own complex lives. And yet here we are today, 7 billion strong and entirely alone. We are the last of the hominids, the sole survivors of a family tree that once branched in magnificent and mysterious ways. Every other human species is gone, leaving only fragments of bone, glimpses of DNA, and an echoing silence where their voices once were. How did this happen? How did we go from a world of multiple human species to a planet with just one? Was it violence, disease, competition for resources, or something else entirely? Perhaps something encoded in our very nature, in the peculiar way our brains work, in the stories we tell ourselves about who we are. Tonight, we're going to explore the strange, beautiful, and sometimes troubling story of how Homo sapiens became the only humans left on Earth. It's a tale that spans hundreds of thousands of years, crosses continents and ice ages, and ultimately leads to you, lying here, listening to these words, the inheritor of an evolutionary lottery that your cousins didn't win. And yet here we are today, 7 billion strong, and entirely alone. We are the last of the hominids, the sole survivors of a family tree that once branched in magnificent and mysterious ways. Every other human species is gone, leaving only fragments of bone, glimpses of DNA, and an echoing silence where their voices once were. How did this happen? How did we go from a world of multiple human species to a planet with just one? Was it violence, disease, competition for resources, or something else entirely? Perhaps something encoded in our very nature, in the peculiar way our brains work, in the stories we tell ourselves about who we are. Tonight, we're going to explore the strange, beautiful, and sometimes troubling story of how Homo sapiens became the only humans left on Earth. It's a tale that spans hundreds of thousands of years, crosses continents and ice ages, and ultimately leads to you, lying here, listening to these words, the inheritor of an evolutionary lottery that your cousins didn't win. Setting the scene meets 2,500 meets 3,000 words. To understand how we became alone, we first need to understand when we weren't. Let's rewind the clock about 300,000 years, to when the first anatomically modern humans, people who looked essentially like us, began to appear in Africa. But beginning is a tricky word when it comes to evolution. We didn't suddenly pop into existence like a light switch being flipped. Instead, populations of our predecessor species, likely Homo heidelbergensis, gradually accumulated the traits we now consider distinctly human. Flatter faces, rounder skulls, smaller teeth, that distinctive chin that juts forward, a feature unique to our species, though nobody really knows why we have it. The fossil record from this period is frustratingly sparse, like trying to reconstruct a novel from a handful of random pages. But what we do have paints a picture of remarkable diversity. At sites like Jebel Irhoud, in Morocco, dated to around 300,000 years ago, we find skulls that are almost modern in their face shape, but retain primitive features in their brain cases. At other African sites, we see different populations experimenting with different evolutionary solutions to the challenge of being human. Meanwhile, The rest of the world was already occupied by other human species who had left Africa in earlier waves of migration. The Neanderthals had been living in Europe and Western Asia for at least 400,000 years by the time our species appeared. They weren't the brutish cave people of popular imagination. They had brains as large as ours, possibly larger. They made sophisticated tools, created art, and may have had language. They were adapted to cold climates in ways we never were, with stocky bodies that conserved heat and enormous nasal cavities that warmed frigid air before it reached their lungs. In Asia, the picture becomes even more complex. Homo erectus, the great wanderer, who had first left Africa nearly 2 million years ago, still survived in pockets across the continent. In Indonesia, they had evolved into unique island forms. In the mountains of Tibet and the forests of Southeast Asia, the mysterious Denisovans, known mostly from DNA and a handful of bones, had carved out their own niche. And then there were the truly enigmatic species. On the Indonesian island of Flores, a species of tiny humans, adults standing just over 3 feet tall with brains the size of chimpanzees, had somehow survived in isolation, hunting dwarf elephants and giant rats. In the Philippines, another small-bodied species, Homo luzonensis, discovered only in 2019, reveals that the human story is still being written, still surprising us. Each of these species represented a different solution to the problem of being human. The Neanderthals solved it with physical power and cold weather adaptations. The Denisovans, from what little we know, seem to have developed unique genetic adaptations to high altitudes. The hobbits of Flores solved it by shrinking, following the island rule that causes many species to become smaller when isolated on islands with limited resources. And what about us? What was our solution? The answer seems to lie not in our bodies but in our minds. Somewhere in Africa, probably between 100,000 and 200,000 years ago, something changed in the way Homo sapiens thought. This wasn't necessarily a biological change. Our brains didn't suddenly get bigger. Instead, it may have been a cultural and cognitive revolution, a new way of using the brains we already had. The archaeological record shows an explosion of symbolic behavior around this time. Suddenly, we see evidence of jewelry, perforated shells that must have been strung together and worn. We find ochre, a red pigment, ground into powder, and possibly used for body painting. We see the deliberate burial of the dead with grave goods, suggesting beliefs about an afterlife. Most remarkably, we see art. The caves of Blombos in South Africa, dated to around 70,000 years ago, contain abstract patterns carved into ochre, crosshatch designs that serve no utilitarian purpose but seem to carry meaning. These aren't doodles or accidents. They're deliberate, repeated patterns that suggest symbolic thought, the ability to let one thing stand for another, the cognitive foundation of language, art, and religion. But here's where the story takes an intriguing turn. This cognitive revolution, if we can call it that, didn't immediately lead to world domination. For tens of thousands of years after developing symbolic thought, our ancestors remained in Africa. When they did finally leave, and genetic evidence suggests there were multiple departures, they entered a world already full of other humans. The first encounters between Homo sapiens and our cousin species must have been extraordinary moments, though we have no direct record of them. Imagine it. You're traveling with your band through new territory, following game or seeking new resources, and you encounter others who are almost like you but not quite. They walk upright like you do. They carry tools. They hunt cooperatively. They care for their injured. But their faces are different, their bodies are shaped differently, and when they speak, if they speak, the sounds they make are alien. How did we recognize each other as similar enough to be human, but different enough to be other? Did we try to communicate? Did we trade? Did we fight? Did we fall in love? That last question isn't as fanciful as it might sound. One of the most stunning discoveries in recent paleoanthropology is that we definitely interbred with other human species. Every person of non-African descent today carries about 1 to 4% Neanderthal DNA. People from Southeast Asia and Oceania carry up to 6% Denisovan DNA. And there are hints of other species in our genome too, ghost populations that we haven't even identified yet. This interbreeding wasn't a one-time event or a rare accident. It happened repeatedly, in different places and times. In fact, we've found first-generation hybrids, individuals with one Neanderthal parent and one Denisovan parent. The boundaries between species, at least among humans, were more fluid than we once thought. But if we could interbreed, if we could produce fertile offspring, were we really different species at all? This question goes to the heart of how we define species, and there's no easy answer. The traditional definition, groups that can produce fertile offspring, breaks down when we look at many real-world examples. Dogs and wolves can interbreed, as can many recognized species. Perhaps it's better to think of human diversity, 50,000 years ago, as a spectrum rather than distinct categories, with gene flow occurring between populations that were nonetheless following different evolutionary trajectories. Yet despite this mixing, despite the evidence of coexistence that sometimes lasted thousands of years, all the other human species eventually disappeared. The last Neanderthals vanished around 40,000 years ago. The Denisovans may have survived until 30,000 years ago, or later. The hobbits of Flores possibly made it to just 50,000 years ago, though some controversial evidence suggests they might have survived until much more recently. What happened to them all? The extinction of our cousin species is one of the great mysteries of human prehistory. For each species, the story was likely different, shaped by local conditions, specific challenges, and the particular dynamics of their interactions with Homo sapiens. But there are patterns, themes that emerge when we look at the broader picture. Let's start with the Neanderthals, because we know the most about them. For 250,000 years, they were the humans of Europe and Western Asia. They survived ice ages that would have crushed less adaptable species. They hunted mammoths and woolly rhinos with nothing but wooden spears and raw courage. They were by any measure one of the most successful human species ever to exist. Yet within a few thousand years of modern humans arriving in Europe, they were gone. The old story was simple: we were smarter, more advanced, and we either killed them or outcompeted them. But the truth is far more complex and interesting. Neanderthals weren't cognitive lightweights. They made sophisticated tools, including the first known specialized bone tools. They created art, abstract patterns, hand stencils, and possibly even cave paintings that predate any known Homo sapiens art in Europe. They made jewelry from eagle talons, and collected interesting stones and fossils, suggesting aesthetic sense and curiosity. They also had complex social behaviors. They cared for their injured and elderly. We found Neanderthal skeletons showing survival for years, with debilitating injuries that would have required constant care. They buried their dead, sometimes with flowers, as suggested by pollen found in graves. They may have had language. Their hyoid bones, crucial for speech, are virtually identical to ours, and genetic analysis shows they had the same variant of the FOXP2 gene that's associated with language in modern humans. So if it wasn't simple cognitive superiority, what was our advantage? One answer might be in the way we organized ourselves socially. Modern humans seem to have lived in larger, more interconnected groups than Neanderthals. Our campsites from this period are larger and show evidence of trade networks spanning hundreds of miles. Shells from the Mediterranean are found at sites in mainland Europe. Particular types of high-quality flint were traded across vast distances. This networking had profound implications. Larger groups mean more ideas, more innovation, more collective knowledge. If one band discovered a better way to make tools or hunt a particular animal, that knowledge could spread through the network. Larger groups also provide insurance against local disasters. If one band suffered from disease or famine, others could help. Neanderthals, by contrast, seem to have lived in smaller, more isolated groups. Their genetic diversity was low, suggesting small population sizes and limited gene flow between groups. When climate changed or prey animals disappeared, They had fewer options, fewer connections to fall back on. But perhaps our most decisive advantage was something stranger, our capacity for shared fiction. Homo sapiens, uniquely among animals, can believe in things that don't physically exist: gods, nations, money, human rights. These shared beliefs allow us to cooperate in massive numbers with strangers we've never met. A Neanderthal band might have been limited to people who knew each other personally, perhaps 50 to 150 individuals. But modern humans could organize around shared myths and symbols, creating tribes, ethnicities, and eventually civilizations comprising millions of individuals. This ability to create and believe in fictional realities might seem like a strange evolutionary advantage, but it transformed our species. It allowed us to coordinate on a scale no other human species could match. It let us adapt to new environments not through biological evolution, but through cultural innovation, new stories, new rules, new ways of organizing ourselves. The climate during this crucial period was also undergoing dramatic shifts. Between 50,000 and 40,000 years ago, Europe experienced wild temperature swings, the Dansgaard-Oeschger events, where temperatures could change by 15 degrees Celsius in a matter of decades. These rapid changes would have stressed all human populations, but modern humans, with their larger networks and cultural flexibility, were better able to adapt. There's also the possibility of disease. When populations that have been separated for hundreds of thousands of years come back into contact, they can exchange pathogens with devastating results. We saw this historically when Europeans reached the Americas, and diseases like smallpox decimated indigenous populations who had no immunity. Something similar might have happened when modern humans met Neanderthals, though the evidence is limited. The story of the Denisovans is even more mysterious. We know them almost entirely from DNA, a finger bone, a few teeth, a piece of skull, and recently, a jawbone from Tibet. But that DNA tells remarkable stories. Denisovans ranged from Siberia to Southeast Asia, and possibly beyond. They interbred with modern humans multiple times, and their genetic legacy is particularly strong in Melanesian populations, who carry up to 6% Denisovan DNA. Some of that DNA provided crucial adaptations. The EPAS1 gene variant that allows Tibetans to thrive at high altitudes comes from Denisovans. Certain immune system genes that help fight off pathogens in Southeast Asia have Denisovan origins. In a very real sense, Denisovans aren't entirely extinct. Fragments of them live on in modern populations, helping us survive in environments our African ancestors never experienced. But as distinct populations, Denisovans disappeared, probably around the time modern humans were spreading through Asia. Were they absorbed into our populations through interbreeding? Did they succumb to competition or disease? The sparse fossil record gives us few clues. The story of Homo floresiensis, the hobbits of Flores, is perhaps the most poignant. These tiny humans, with their tiny brains, managed to survive on their island for hundreds of thousands of years. They made stone tools, hunted elephants, albeit dwarf elephants, and dealt with Komodo dragons and giant storks. Their small brain size challenges our assumptions about intelligence. Somehow, with a brain the size of a chimpanzee's, they managed to master fire and create tools as sophisticated as those made by other human species with much larger brains. They disappeared around 50,000 years ago, suspiciously close to when modern humans first arrived in the region. But was it our direct impact, or did we disrupt the delicate island ecosystem they depended on? Did we introduce diseases, or compete for the same resources? The evidence is too limited to say for certain. What we can say is that by around 30,000 years ago, and possibly much more recently, Homo sapiens stood alone. Every other experiment in humanity had ended. We were the sole survivors of millions of years of hominid evolution. But survival, it turns out, is just the beginning of the story. What happened after we became the only humans on Earth is in some ways even stranger than how we got there. Almost immediately after the last of our cousins disappeared, Something extraordinary happened. The Upper Paleolithic Revolution. Suddenly human culture exploded in complexity. We see elaborate cave paintings like those at Lascaux and Chauvet, so sophisticated that when they were first discovered, many believed they must be modern forgeries. We find musical instruments, flutes carved from bird bones and mammoth ivory. We see evidence of long-distance trade networks spanning continents. It's as if the disappearance of other human species freed something in us, removed some constraint on our cultural evolution. Or perhaps it was the other way around. Perhaps this cultural explosion was what finally gave us the edge that led to their extinction. But here's the truly unsettling thought. We didn't just outlast our cousin species, we may have actively caused their extinction. The timing is too suspicious to ignore. Wherever modern humans arrived, other human species disappeared shortly after. In Europe, Neanderthals vanished within a few thousand years of our arrival. In Asia, the pattern repeats with Denisovans and other species. Even on isolated islands like Flores, the appearance of modern humans coincides with the disappearance of other hominids. Were we directly responsible? The evidence is circumstantial but compelling. We don't find clear evidence of warfare or mass killings, but extinction doesn't require genocide. Simply outcompeting other species for resources, disrupting their ecosystems, or introducing diseases could have been enough. We may have been unwitting exterminators, not through malice, but through the inexorable pressure of our success. And this pattern, arriving somewhere new and causing extinctions, didn't stop with other human species. Wherever modern humans went, megafauna disappeared. Australia lost its giant kangaroos and wombats the size of rhinos shortly after humans arrived 65,000 years ago. Europe and Asia lost their mammoths, woolly rhinos and cave bears. The Americas lost their giant ground sloths, saber-toothed cats, and dozens of other large species soon after humans crossed the Bering Land Bridge. We were and are a catastrophe for other large species. Our combination of intelligence, social cooperation, and technological innovation made us unprecedentedly effective predators and competitors. We didn't just adapt to ecosystems, we transformed them, often in ways that other species couldn't survive. So here we are, the last hominids, inheritors of an empty throne. We carry within us genetic echoes of our vanished cousins, a few % of DNA that whispers of encounters in the deep past, moments when different kinds of humans met, and despite their differences, found enough common ground to create life together. In a sense, we're not purely Homo sapiens anymore. We're hybrids, carrying genetic gifts from species that no longer exist in their pure form. The Neanderthal DNA that helps some people fight off diseases, the Denisovan genes that let Tibetans breathe easily at high altitudes, these are inheritances from our lost relatives, final gifts from cousins we'll never meet again. When you look in the mirror, you're seeing the result of hundreds of thousands of years of evolution, migration, adaptation, and yes, extinction. You're seeing the last human standing, the sole survivor of a once diverse family. Every other version of humanity, the strong Neanderthals, the mysterious Denisovans, the tiny hobbits of Flores, is gone. Their stories ended, while ours continued. It's a profound loneliness when you think about it. We search the cosmos for intelligent life, spending billions on telescopes and transmitting messages to the stars, but we once had intelligent company right here on Earth. We shared this planet with other kinds of humans who looked at the same stars and wondered perhaps what they meant. What would the world be like if they had survived? If Neanderthals still lived in Europe, if Denisovans still roamed Asia, if tiny humans still hunted dwarf elephants on tropical islands, would we have learned to coexist? Would we have carved up the planet into human species zones? Would the presence of other kinds of humans have made us less likely to divide ourselves by race, religion, or nation, recognizing these as trivial differences compared to species-level distinctions? Or would it have been worse? Would we be in constant competition, even war? Would the presence of other human species have been used to justify even greater cruelties than those our species has already committed against itself? We'll never know. That alternate history, that world of multiple humanities, is lost to us. We're alone now, the only humans in a universe that seems increasingly empty of intelligent life. But perhaps there's something beautiful in that loneliness too. We carry the torch for all of them, for every experiment in humanity that didn't make it. When we create art, we're not just expressing Homo sapiens' creativity, but continuing a tradition that Neanderthals began when they painted on cave walls. When we adapt to harsh environments, we're using genetic gifts from Denisovans, and perhaps other species we haven't even identified yet. We are, in a very real sense, the sum of all humanities, the final repository of millions of years of hominid evolution. We're not just Homo sapiens, we're the last chapter in a story that began when the first apes stood upright and looked beyond the trees. And what a chapter we're writing. In the mere 30,000 years since we became the only humans, we've transformed ourselves and our planet in ways that would seem like magic to our ancestors. We've gone from painting on cave walls to transmitting images across the globe instantly. We've gone from fearing the darkness to creating artificial suns. We've gone from being one species among many to being the single species that will determine the fate of life on Earth. That's the weight we carry as the last hominids. We're not just responsible for our own survival but for the continuation of the human experiment itself. Every decision we make, from how we treat our environment to how we develop our technologies, carries the weight of being the only human voice in the cosmos. Tonight, as you drift off to sleep, remember that you're part of an extraordinary story, the story of the species that survived when all its cousins didn't. You carry within your cells the history of encounters between different kinds of humans. You embody the cultural innovations that gave our ancestors the edge they needed to persist when others couldn't. You are, in every sense, the last of your kind, the last hominid, the sole survivor of humanity's diverse family tree. It's a sobering thought, but also an inspiring one. We made it this far, through ice ages and volcanic winters, through genetic bottlenecks where our entire species numbered fewer than 10,000 individuals, through the loneliness of losing every other version of humanity we once knew. Sleep well, last hominid. Dream of the ancestors you never knew, the cousins you'll never meet, the alternative humanities that might have been, and wake tomorrow to continue writing the only human story left to tell, ours. But let's delve deeper into what it means to carry the genes of extinct humans within us. Because this is where the story becomes intensely personal. Yes, you lying there listening to this, are not purely human. At least not in the way we once defined it. You're a mosaic, a patchwork of different human species that merged, separated and merged again across thousands of years. If you have European or Asian ancestry, roughly 2% of your genome comes from Neanderthals. That might not sound like much, but it represents millions of base pairs of DNA, affecting everything from your immune system to your sleep patterns. Some people carry genes that affect their risk of depression, their tendency toward addiction, or their response to certain medications, all gifts or curses from Neanderthal ancestors who died 40,000 years ago. The Neanderthal DNA isn't randomly distributed through our genomes either. Natural selection has been steadily removing Neanderthal DNA from certain parts of our genome while preserving it in others. Neanderthal genes involved in brain development and testis function have been largely eliminated, suggesting that hybrid fertility or cognitive function may have been compromised. But Neanderthal genes affecting skin and hair have been retained, particularly in populations living at high latitudes where these adaptations to low UV light prove beneficial. Think about that, when you next see your skin flush in the cold or notice how quickly you tan or burn in the sun. These reactions might be shaped by genes from another species, a biological memory of humans who evolved under European Ice Age conditions. The Denisovan contribution is even more dramatic in some populations. Indigenous peoples of Papua New Guinea carry up to 6% Denisovan DNA, and this genetic heritage provides real, measurable benefits. The EPAS1 gene variant that Tibetans inherited from Denisovans allows them to thrive at altitudes where most humans would suffer from chronic mountain sickness. Without this Denisovan gift, The high plateaus of Tibet might never have been permanently settled, but there are ghosts of other species too, shadows in our genome that we can detect but not identify. Africans, who lack Neanderthal and Denisovan DNA because their ancestors never left Africa to encounter these species, nonetheless show signs of interbreeding with unknown ancient humans. Who were these ghost populations? When did these encounters occur? We don't know, but their genetic signatures persist, shaping who we are in ways we're only beginning to understand. Around 70,000 years ago, something unprecedented happened. Homo sapiens began to exhibit what researchers call behavioral modernity, the full package of symbolic thought, complex language, and cumulative culture that defines us today. This wasn't a biological revolution. Our brains didn't suddenly get bigger or fundamentally restructure. Instead, it was a software update, a new way of using the hardware we already had. The evidence for this revolution is stunning. Before this period, the archaeological record is relatively monotonous. The same stone tools made the same way for hundreds of thousands of years. After this period, we see an explosion of innovation. New tools appear and spread rapidly. Art becomes commonplace. Trade networks span continents. But perhaps the most important innovation was the ability to transmit complex culture across generations. Other species had culture. Neanderthals had different tool-making traditions in different regions, suggesting cultural transmission. But Homo sapiens developed cumulative culture, where innovations build on previous innovations, where knowledge accumulates rather than being repeatedly rediscovered. This ability to accumulate cultural knowledge changed the rules of the evolutionary game. Adaptation no longer required genetic change over thousands of generations. Instead, we could adapt through cultural innovation in a single generation. When we entered new environments, we didn't wait for evolution to give us thicker fur or different metabolisms. We invented clothing, controlled fire, and developed new hunting strategies. This cultural flexibility may have been our decisive advantage over other human species. While Neanderthals were beautifully adapted to Ice Age Europe through hundreds of thousands of years of evolution, we could achieve similar cold weather survival through cultural innovations, better clothing, more sophisticated shelters, more efficient hunting strategies, in just a few generations. Their quote. Something deeply melancholic about being the only surviving human species. We've lost not just genetic diversity, but entire ways of being human. Each extinct species represented a different solution to consciousness, a different way of experiencing and understanding the world. Neanderthals, with their larger brains and different neural organization, might have thought in ways we can't imagine. Their material culture suggests they were more conservative than us, maintaining the same tool traditions for tens of thousands of years. But was this cultural stagnation or a different relationship with time and change? Did they have a deeper connection to place, to tradition, to the rhythms of the natural world that we've lost in our restless innovation? The Denisovans remain almost entirely mysterious, known mainly from their genetic legacy. But that legacy hints at remarkable adaptations. They gave Tibetans the ability to thrive at altitude, and Southeast Asians immune system variants that fight tropical diseases. What other gifts might they have carried? What unique perspectives on the world died with them? And the hobbits of Flores challenge our most basic assumptions about intelligence. With brains 1/3 the size of ours, they managed to create tools, control fire, and successfully hunt prey much larger than themselves. They remind us that there isn't just one way to be intelligent, that consciousness might not require the massive brains we've developed. Being the last human species carries a unique psychological burden. We have no peers, no other species we can look to and say, they understand what it's like to be aware, to question, to wonder about meaning and mortality. We search for intelligence in dolphins, great apes, elephants, and find glimmers but not equals. We scan the cosmos for signals from alien civilizations, desperate for confirmation that consciousness exists elsewhere. This cosmic loneliness might explain some of our species' more troubling characteristics. Our tendency to divide ourselves into tribes, races, and nations might be an attempt to recreate the species diversity we've lost. Our simultaneous fascination with and fear of the other might be an echo of ancient encounters with different human species. It might also explain our relentless drive to modify ourselves through culture, technology, and increasingly through direct biological intervention. We're recreating human diversity. We're becoming cyborgs with our smartphones and computers. We're editing our genes with CRISPR. We're imagining uploading our consciousness to machines or enhancing our cognition with neural implants. In a sense, we're trying to escape the limitations of being a single species, to recreate the diversity we lost when our cousins went extinct. We're trying to become multiple humanities again, this time through technology rather than evolution. The disappearance of other human species marked the beginning of something unprecedented in Earth's history, the complete domination of the planet by a single species. No other single species has ever had such a profound impact on the global environment, climate, and other life forms. This impact began almost immediately after we became the only humans. The megafaunal extinctions that followed our spread across the globe were just the beginning. As we developed agriculture, we began reshaping entire landscapes. As we built cities, we created entirely new ecosystems. As we industrialized, we began changing the very chemistry of the atmosphere and oceans. We've become a geological force comparable to volcanoes or glaciers. Future geologists will be able to identify our era by the sudden appearance of plastics and sediments, by the spike in radioactive isotopes from nuclear testing, by the rapid shift in atmospheric chemistry. We've initiated the sixth mass extinction in Earth's history, with species disappearing at rates not seen since the asteroid that killed the dinosaurs. But unlike that asteroid, we're aware of what we're doing. We have the unique ability among Earth species to understand our impact and potentially change course. We can model future scenarios, predict consequences, and consciously choose different paths. Whether we will is another question entirely. So what comes next for the last hominid? Our story is far from over, and the paths ahead are both thrilling and terrifying. One possibility is that we're about to recreate human diversity through technology. Gene editing, cybernetic enhancement, and artificial intelligence might create new forms of humanity as different from current humans as we are from Neanderthals. We might see the emergence of enhanced humans with improved cognition, disease resistance, or even the ability to survive in environments like Mars or the vacuum of space. Already we're seeing the early stages of this diversification. Some humans have magnetic implants that let them sense electromagnetic fields. Others have chips that allow them to open doors or pay for goods with a wave of their hand. As these technologies become more sophisticated and widespread, we might see the emergence of distinct human subspecies, not through natural evolution but through conscious choice. There's also the possibility of creating artificial consciousness that equals or exceeds human intelligence. If we succeed, we'll no longer be alone as conscious, questioning beings. We'll have created our own companions in consciousness, ending the loneliness of being the only self-aware species. Of course, this raises profound questions about the rights of artificial beings, about what it means to be human, about our place in a world where we're no longer the only, or even the most intelligent species. Climate change and environmental destruction pose existential challenges that will test our species like nothing since the last ice age. Rising seas, shifting agricultural zones, mass migration, and resource conflicts could fragment our global civilization. Different populations might adapt in different ways, potentially leading to new forms of human diversity, or to our extinction. There's even the possibility that we're not as alone as we think. As we explore the solar system and develop more sophisticated techniques for detecting life, we might discover that consciousness is more common than we believed. Perhaps we'll find microbial life on Mars or in the subsurface oceans of Europa. Perhaps we'll detect biosignatures in the atmospheres of exoplanets. Perhaps we'll even receive a signal from another technological civilization. Being the last human species gives us unique moral responsibilities. We're not just responsible for our own survival but for the continuation of consciousness on Earth, possibly in the universe. Every decision we make, about the environment, about technology, about how we organize our societies, carries the weight of being potentially the only conscious beings making such decisions. We're also the only species capable of understanding and potentially reversing the damage we've caused. We can bring species back from the brink of extinction. We can restore damaged ecosystems. We can potentially even revive extinct species through de-extinction technologies. Some scientists are seriously discussing the possibility of bringing back Neanderthals using genetic engineering, raising profound ethical questions about our right to resurrect our extinct cousins. Our treatment of other conscious or potentially conscious beings becomes even more important when we consider that we're the only judges of consciousness. How we treat great apes, cetaceans, elephants, and other intelligent species reflects not just on us but on the value of consciousness itself. If we, the only known fully conscious beings, don't value consciousness in others, what does that say about the universe's capacity for ethics and compassion? Perhaps the most important consequence of being the last human is the power it gives us to define what humanity means. With no other human species to compare ourselves to, we get to write the entire definition. We decide what's essentially human and what's culturally variable. We determine the boundaries of human nature and human potential. This power is both liberating and dangerous. It allows us to imagine and create new forms of human existence, to push beyond biological limitations, to expand our consciousness in ways our ancestors never imagined. But it also means we can make catastrophic mistakes with no other human species to provide alternative models or to carry on if we fail. The stories we tell about our past shape our future. If we see ourselves as inevitable winners in an evolutionary competition, we might feel justified in our dominance over other species. If we see ourselves as lucky survivors who happen to develop the right traits at the right time, we might feel more humble about our place in the world. If we see ourselves as carrying the legacy of all extinct humans, we might feel a greater responsibility to honor that diversity. If we could send a message back through time to our extinct cousins, what would we say? To the Neanderthals: we carry your strength within us. Your genes help us survive diseases, endure cold climates, and perhaps even think in ways we don't fully understand. The art you created, the loved ones you buried with flowers, the injured you cared for, these acts of beauty and compassion echo through time. You were not the brutes we once imagined, but fellow humans who looked at the same stars and wondered. To the Denisovans, though we barely know you, your genetic gifts have allowed humans to inhabit places we never could have survived without you. The mountains of Tibet, the islands of Southeast Asia, these are monuments to your evolutionary innovations. In the cells of millions of living humans, you continue your journey. To the hobbits of Flores, you showed us that humanity doesn't require the big brains we're so proud of. With a third of our neural capacity, you mastered fire, created tools, and survived for hundreds of thousands of years. You remind us that intelligence comes in forms we don't always recognize, that consciousness might be far more flexible than we imagine. To all the ghost populations whose names we'll never know, you are the shadows in our genome, the mysterious ancestors who shaped us in ways we're still discovering. Every human alive carries traces of encounters we can't remember, meetings between different kinds of humans that produced children, and through them, us. What do we dream of? We last humans. Our dreams are haunted by the diversity we've lost, and the diversity we might create. We dream of de-extinction, of using genetic engineering to bring back the mammoth, the dodo, maybe even the Neanderthal. We dream of creating new forms of life, of designing organisms to clean up our pollution, to terraform Mars, to serve as biological computers. We dream of transcendence, of uploading our consciousness to machines, of escaping the biological limitations that constrain us. We dream of immortality, of spreading across the galaxy, of ensuring that consciousness, in whatever form, never goes extinct. But we also dream darker dreams. We dream of nuclear winter, of climate catastrophe, of engineered plagues that could end our reign as abruptly as we ended our cousins. We dream of artificial intelligences that surpass us, making us as obsolete as we made the Neanderthals. We dream of a silent Earth, where the last human's death means the end of all consciousness in the known universe. Or our success as the sole surviving human species contains the seeds of its own undoing. The same traits that allowed us to outcompete our cousins now threaten our existence. Our ability to cooperate in large numbers led to civilization, but also to wars that killed millions. Our capacity for abstract thought gave us science, but also ideologies that justified genocide. Our tool-making abilities gave us technology that can either save or destroy us. Our adaptability allowed us to spread across the planet, but also to damage every ecosystem we touched. We're like a fire that's consumed all available fuel, and now must either find new sources of energy or burn out. Can we transform from a species that succeeds through expansion and consumption to one that succeeds through sustainability and wisdom? Can we evolve, culturally if not biologically, fast enough to survive our own success? Despite everything, despite the extinctions we've caused, the environments we've damaged, the cousins we've lost, we remain Earth's only known attempt at consciousness capable of understanding itself. We're the universe becoming aware of itself. In Carl Sagan's beautiful phrase, every human child born is another roll of the dice, another experiment in consciousness. Each carries unique combinations of ancient genes, including fragments from extinct humans, mixed in ways that have never existed before and will never exist again. Each has the potential to think thoughts that have never been thought, to see connections that have never been seen, to solve problems that have never been solved. In this sense, human diversity hasn't ended with the extinction of other species. It's exploded into billions of unique variants, each a different expression of what it means to be human. We may be one species, but we contain multitudes. Sometimes, late at night, it feels like we're being watched, not by aliens or gods, but by the ghosts of our extinct cousins. What would they make of what we've become? Would Neanderthals recognize themselves in our art, our music, our care for the vulnerable? Would they see their own love of beauty in our museums and concert halls? Would Denisovans find echoes of their mountain-dwelling adaptations in our base camps on Everest, our space stations orbiting Earth? Would the hobbits of Flores see their resourcefulness reflected in our ability to thrive in every environment on Earth and beyond? Or would they see us as something altogether different, something they couldn't have imagined, a species that has transcended biology through culture, that has become something more and less than human? Being the only known conscious species in the universe as far as we know gives us a unique responsibility to preserve and propagate consciousness in whatever form it takes. This doesn't necessarily mean preserving Homo sapiens forever. It might mean creating new forms of consciousness through artificial intelligence. It might mean enhancing human consciousness through genetic engineering or cybernetic augmentation. It might mean spreading Earth-based life to other worlds, ensuring that consciousness survives even if Earth doesn't. But it definitely means recognizing the preciousness of awareness itself. Every conscious moment yours right now, listening to these words, is the universe experiencing itself. Every thought, every feeling, every observation is cosmos looking at cosmos, matter contemplating matter, existence acknowledging existence. We're not just the last humans, we're the universe's only known attempt at understanding itself. That makes us unspeakably precious, regardless of our flaws, our mistakes, our destructive tendencies. We're the only things in the known universe that can appreciate beauty, ponder meaning, or feel love. From the perspective of deep time, our moment as the only human species is vanishingly brief. Hominids have existed for about 7 million years. Our species has existed for 300,000 years. We've been alone for perhaps 30,000 years. In geological terms, that's an eye blink. What comes next? In 1,000,000 years, if we survive, we almost certainly won't be Homo sapiens anymore. Evolution doesn't stop. Even if it's now more cultural and technological than biological, we'll have become something else, perhaps multiple something else. Maybe we'll diversify again, not through natural selection but through conscious choice. Maybe populations on different planets will diverge into distinct species. Maybe we'll merge with our machines to become something entirely new. Maybe we'll engineer ourselves into forms we can't currently imagine. Or maybe we'll be gone, another extinct branch on the tree of life, our cities crumbling to dust, our satellites falling from the sky, our radio signals spreading ever outward through an empty cosmos, ghostly echoes of a species that burned bright and brief. There's a profound loneliness in being the only humans. We have no one to compare ourselves to, no one to learn from, no one to share the burden of consciousness with. We're alone with questions that may have no answers, searching for meaning in a universe that may have none to offer beyond what we create. But there's wonder, too. We're the only species that knows the age of the universe, that has seen galaxies billions of light years away, that has touched the moon and sent robots to Mars. We're the only species that can read the genetic code, that can split the atom, that can compose symphonies and write poetry. We're the only species that can remember the extinct, that can mourn the Neanderthals, wonder about the Denisovans, and marvel at the hobbits of Flores. In our memories and our science, they live on, not as living beings, but as part of the story we tell about ourselves. Our bones carry messages from deep time, the shape of our skulls, the arch of our feet, the dexterity of our hands. All of these are texts written by evolution, edited by natural selection, annotated by chance. But now we're learning to read other messages too. The DNA in our cells tells stories of ancient migrations, of populations that mixed and separated, of adaptations to environments that no longer exist. We can trace the journey of our ancestors through genetic markers, following them out of Africa, across continents, through ice ages and warm periods, through meetings with other humans, and long isolations. Every human alive is a library of these stories. Your DNA contains information about plagues that struck thousands of years ago, about dietary changes when agriculture was invented, about encounters between different human populations in prehistory. You are a walking archive of human evolution. So here we are, at the end of our journey through the story of the last hominid, and we're left with the ultimate question: what does it mean to be human when there's only one kind of human left? Without other human species to define ourselves against, we've had to create our own definitions. We've said humans are tool users, but other animals use tools. We've said humans have language, but other species communicate in complex ways. We've said humans are conscious, but we don't really know what consciousness is, or whether other species have it. Maybe being human simply means being the inheritor of this particular evolutionary story, the species that survived when others didn't, that carries within itself genetic and cultural echoes of all the other human experiments. Maybe it means being the only species capable of asking what it means to be human, or maybe the question itself is the answer. Maybe being human means being the kind of being that wonders about being, that tells stories about origins and endings, that looks at the stars and feels both insignificant and infinite. And now, as you drift towards sleep, let me leave you with a lullaby for our species, the last of the hominids. You are the product of millions of years of evolution, of countless generations who survived long enough to pass on their genes. You carry within you the strength of survivors, the curiosity of explorers, the creativity of artists who painted on cave walls tens of thousands of years ago. You are part Neanderthal, part Denisovan, part ghost populations, whose names we'll never know. You are a hybrid, a mixture, a beautiful combination of different human experiments that merged into something new. You are the only human species left, but you are not alone. You're connected to every other human alive through shared ancestry that goes back hundreds of thousands of years. You're connected to every human who has ever lived through an unbroken chain of parents and children, stretching back to the dawn of our species. You are the universe's only known way of understanding itself, the cosmos developing consciousness, matter achieving awareness. In you, hydrogen atoms forged in the Big Bang have become complex enough to contemplate their own origins. You are fragile, a few pounds of pressure in the wrong place, a few degrees of temperature change, a few minutes without oxygen, and consciousness ends. But you are also resilient, part of a species that has survived ice ages, supervolcanic eruptions, plagues, and the lonely journey to becoming the only humans left. You are temporary. Your individual consciousness will last only decades, a flash in cosmic time. But you are also part of something potentially eternal, a chain of consciousness that has lasted hundreds of thousands of years, and might last billions more, if we're clever and lucky. Sleep well, last hominid. Dream of your ancestors who looked at the same stars and wondered. Dream of your cousins who are gone but not forgotten, who live on in your genes and in the stories we tell. Dream of futures, where humanity in whatever form it takes continues its journey through the cosmos. And when you wake, remember that you are extraordinary, not because you're perfect, but because you exist at all. You are the universe's way of knowing itself, the only voice in the known cosmos that can say I am and understand what that means. You are Homo sapiens, the wise human, though wisdom often eludes us. You are the last hominid, alone but not lonely, singular but not separate, one species but infinite in variation. You are human, and for now, in this vast, mostly empty universe, that's everything. But let's go deeper into what it truly means to be alone as a species, because this loneliness has shaped everything about how we see ourselves and our place in the universe. When multiple human species coexisted, there was a living reminder that there were other ways to be human. Different body shapes, different brain structures, different solutions to the challenge of consciousness. The Neanderthals with their massive muscle attachments and barrel chests represented one path, the gracile Denisovans another, the tiny Flores hobbits yet another. Each was a living experiment in humanity, a different answer to the question, what does it mean to be a conscious tool-using primate? Their presence would have provided a kind of cognitive anchor, a constant reminder that our way of being human wasn't the only way, wasn't inevitable, wasn't necessarily superior, just different. But when they disappeared, we lost that perspective. We became the sole arbiters of humanity, the only judges of what's natural, what's possible, what's desirable in human form and behavior. This has had profound psychological consequences. Without other human species to compare ourselves to, we've turned inward, creating artificial divisions among ourselves. Race, ethnicity, nationality, religion. These have become our substitute for species diversity. We've created others, where none exist biologically, drawing boundaries that would seem absurd if Neanderthals still walked among us. Think about how different our history might have been. Would we have enslaved other Homo sapiens if we could have pointed to actual different human species? Would racism exist in the same way if we had real species-level differences to compare to our minor variations in skin color and features? Would we have been forced to develop a more nuanced understanding of consciousness, intelligence, and worth if we shared the planet with beings who were clearly human but clearly different? One aspect of our success that's rarely discussed is our unique metabolic flexibility. Homo sapiens can survive on an extraordinary range of diets, from the pure meat diet of Arctic peoples to the largely vegetarian diets of agricultural societies. This flexibility isn't just cultural, it's biological, encoded in our genes and our gut bacteria. When we left Africa, we encountered environments where the foods we evolved eating simply didn't exist. No fruits in the Arctic, no large game in many island environments. Different plants, different animals, different seasonal patterns everywhere. Yet we adapted, not through biological evolution, that would have taken too long, but through metabolic flexibility and cultural innovation. We learned to detoxify plants that would poison other species. We developed techniques like nixtamalization to make corn nutritious, fermentation to preserve foods and increase their nutritional value, cooking to extract more calories from tough plant materials and meat. We formed symbiotic relationships with bacteria that could digest things we couldn't, essentially outsourcing part of our digestion to microorganisms. Other human species seem to have been more metabolically specialized. Neanderthals, based on isotope analysis of their bones, appear to have been heavily carnivorous, essentially apex predators. This would have made them vulnerable to the decline of megafauna at the end of the Ice Age. When the mammoths and woolly rhinos disappeared, so did a major part of their food supply. The hobbits of Flores, living on an island with limited resources, seem to have adapted to a very specific diet of local foods. When we arrived and disrupted their ecosystem, introducing new species, hunting their prey, perhaps bringing diseases that affected their food sources, they couldn't adapt quickly enough. But Homo sapiens could eat anything, survive anywhere. We could switch from hunting to gathering to fishing to farming, sometimes within a single generation. This metabolic flexibility, combined with our cultural ability to process foods in novel ways, meant we could colonize any environment on Earth. Language may have been our ultimate weapon in the competition with other human species. Not just simple communication, other species certainly communicated, but fully symbolic, grammatically complex, infinitely expressive language. The evolution of language is one of the most contentious topics in paleoanthropology. We can't fossilize words, can't excavate grammar, but we can look at the indirect evidence, the anatomical requirements for speech, the cognitive requirements for language processing, the archaeological evidence for symbolic thought. The hyoid bone, crucial for speech, is nearly identical in Homo sapiens and Neanderthals, suggesting both species had the anatomical capability for complex vocalization. The FOXP2 gene, associated with language in modern humans, is also present in the same form in Neanderthals. So why did we survive and they didn't? If both species could speak, the answer might lie not in the ability to produce speech, but in how we use language. Homo sapiens seems to have developed what linguists call displacement, the ability to talk about things that aren't present, things that happened in the past or might happen in the future, things that exist only in imagination. This capacity for displaced reference transforms language from a communication tool into a cognitive tool. We can plan complex future activities. We can share knowledge about distant places and past events. We can create shared fictions, gods, nations, laws that coordinate behavior across vast groups of strangers. Neanderthals might have had language, but perhaps not this kind of language. Their conservative tool traditions, lasting unchanged for tens of thousands of years, suggest less cultural transmission, less teaching, less accumulated knowledge passed between generations. They might have communicated about the here and now, but struggled with abstract concepts, future planning, or complex narratives. The linguistic Big Bang that happened in Homo sapiens sometime between 100,000 and 50,000 years ago wasn't just about communication. It was about creating shared realities that existed nowhere but in the collective human mind. These shared fictions allowed us to cooperate on scales no other species could match. We need to talk about the psychological impact of causing extinctions, because we've been doing it for so long that it's become part of our collective unconscious. Every human culture has myths about giants, ogres, trolls, or other humanoid beings that once walked the earth. These stories are found everywhere, from Europe to Asia to the Americas. Could these be cultural memories of encounters with other human species? Neanderthals were notably robust and strong. Might they be the giants of our myths? The tiny Flores hobbits, might they be the source of stories about little people, fairies, or dwarves? We can't know for certain, but the universality of these myths suggests something deep in our collective memory, some echo of a time when we weren't alone. The disappearance of these others might have been traumatic in ways we don't fully appreciate. Consider the psychological impact on those early Homo sapiens who witnessed the last Neanderthals, who perhaps even knew them as individuals, traded with them, maybe even loved them. The guilt, the loss, the sudden loneliness of being the only humans left, these emotions might have shaped our psychology in profound ways. Our obsession with monsters, with the almost but not quite human, might stem from this ancient trauma. Vampires, zombies, werewolves, all are essentially corrupted humans, beings that look like us, but aren't quite right. Are these the psychological fossils of our extinct cousins, transformed by time and storytelling into creatures of nightmare. One of the most tragic consequences of becoming the only human species is that we invented race as a substitute for genuine species diversity. The biological differences between human populations are trivial. We're one of the most genetically uniform species on Earth, with more genetic diversity in a single troop of chimpanzees than in all humans globally. Yet we've convinced ourselves that these minor variations, skin color, hair texture, facial features, represent fundamental differences. We've created hierarchies, justified slavery and genocide, fought wars over differences that would seem laughably minor if we still shared the planet with Neanderthals or Denisovans. The irony is heartbreaking. We eliminated genuine human diversity, entire species with different ways of thinking, different adaptations, different perspectives on existence. Then we created artificial diversity based on superficial traits and convinced ourselves it was profound. Racism might be an evolutionary misfiring, a cognitive system designed to distinguish between different human species, now creating false categories within our single species. The parts of our brain that once helped us recognize the difference between Homo sapiens and Homo neanderthalensis now desperately seek patterns, creating us and them where only us exists. Our technological prowess, which gave us such an advantage over other human species, has become both our greatest asset and our greatest threat. Other human species develop technology too, but slowly, carefully, sustainably. Neanderthals used essentially the same tools for hundreds of thousands of years. When they innovated, it was gradual, tested over generations. Their technology was in equilibrium with their environment. But Homo sapiens innovates compulsively, obsessively, dangerously. We create new technologies faster than we can understand their implications. We transform our environment faster than we can adapt to the changes. We're like a species in permanent revolution, never stable, never satisfied, always pushing toward the next innovation. This served us well when competing with other human species. Our rapid innovation in weapons, tools, and social organization gave us decisive advantages. But now, with no competitors, our innovative drive is consuming the planet. We're innovating ourselves toward potential extinction through climate change, nuclear weapons, artificial intelligence, and technologies we haven't even invented yet. It's as if we're still competing, still racing, but the race is over and we can't stop running. We're competing against ourselves, against our past achievements, against imaginary future threats. The very trait that ensured our survival might ensure our destruction. Our desperate search for other intelligent life, through SETI, through space exploration, through attempts to communicate with dolphins and apes, might be driven by the loneliness of being the only human species. We spend billions on telescopes and space missions, searching for signals from alien civilizations. We teach sign language to apes, hoping to find another mind we can truly communicate with. We study dolphin vocalizations, elephant communication, hoping to discover that we're not as alone as we fear. This search isn't just scientific curiosity, it's an existential need, a deep psychological drive to find others who can understand what it's like to be conscious, to be aware, to wonder about meaning and mortality. We had that once, in our cousin species. We lost it, and we've been searching for a replacement ever since. The possibility that we might be alone in the universe, not just as the only human species but as the only intelligent life, is almost too terrible to contemplate. It would mean that consciousness is even rarer than we thought, that the universe's capacity for self-awareness rests entirely on our fragile species. When other human species went extinct, we lost not just genetic diversity, but entire ways of dreaming, imagining, and understanding the world. Neanderthal brains were organized differently from ours. Their occipital lobes were larger, possibly giving them superior vision. Their parietal lobes were shaped differently, potentially affecting spatial processing. They might have perceived the world in ways we can't imagine, seen colors we can't see, noticed patterns we miss. What did they dream about? What were their myths, their gods, their explanations for existence. Did they have music that followed different scales, art that expressed different aesthetics, stories that took different forms? All of this is lost, erased from the universe, except for the faintest archaeological traces. The Denisovans remain almost entirely mysterious. We know them mostly from their genetic legacy, but genes don't preserve thoughts, beliefs, or dreams. What unique insights did they have? What solutions to existential questions did they develop? We'll never know. The hobbits of Flores, with their tiny brains, challenge our assumptions about consciousness itself. If they were conscious, and their tool use and fire control suggest they were, what was their consciousness like? Was it simpler than ours, or just different? Did they have a more direct, less abstract experience of reality? Each extinct human species took with them unique ways of being conscious. We're left with just one perspective, one way of experiencing existence. It's like having a symphony, where all but one instrument has fallen silent. We are the only species that remembers the extinct, that carries the burden of knowing what's been lost. No other animal mourns species extinctions or feels guilt about causing them. This unique cognitive capacity, to understand extinction, to feel responsible for it, is both a curse and a potential salvation. We know what we've done. We've mapped the extinctions that followed our spread across the globe. We've identified the genetic ghosts in our genome. We've reconstructed the lives and deaths of our cousin species. This knowledge weighs on us, or at least it should, but memory also gives us the power to learn, to change, to avoid repeating past mistakes. We're the first species in Earth's history that can consciously choose to prevent extinctions rather than cause them. We can use our understanding of the past to shape a different future. The question is whether we will, whether the same species that eliminated all other humans can learn to coexist with the rest of life on Earth. Whether we can transform from destroyer to protector, from competitor to guardian. Let's talk more personally about what it means to carry Neanderthal DNA, because this isn't just an abstract scientific fact. It affects your daily life in ways you might not realize. If you have European ancestry, your immune system's first line of defense includes Neanderthal contributions. The genes TLR1, TLR6, and TLR10, involved in recognizing and responding to pathogens, often come in Neanderthal variants in non-African populations. These genes help you fight off bacteria, fungi, and parasites, a gift from cousins who died 40,000 years ago but who still protect you today. Your risk for certain diseases is also influenced by Neanderthal DNA. Type 2 diabetes, Crohn's disease, lupus, and even severe COVID-19 symptoms have been linked to Neanderthal genetic variants. It's as if our ancient hybridization created biological time bombs that are still going off tens of thousands of years later. But it's not all negative. Neanderthal genes affecting keratin production influence your hair and skin characteristics. They might make your hair thicker, your skin better at producing vitamin D in low light conditions. If you tan easily, or have a certain hair texture, you might be expressing Neanderthal adaptations to European climates. Even your mood and behavior might be influenced by Neanderthal genes. Certain variants associated with depression and addiction are more common in people with higher Neanderthal ancestry. The same genes that might have helped Neanderthals survive in harsh Ice Age conditions, perhaps by making them more cautious or more focused on immediate rewards, now influence how our brains respond to modern stressors. Some researchers even suggest that Neanderthal DNA might influence skull shape and brain development in subtle ways, not enough to be visible, but perhaps enough to influence how we think, how we process information, how we experience the world. You are, in a very real sense, part Neanderthal, not in some abstract ancestral way, but in the functioning of your cells, the shape of your proteins, the responses of your immune system. Every day, Neanderthal genes are transcribed in your cells, Neanderthal proteins are synthesized in your ribosomes, Neanderthal adaptations help you survive. The world is quieter now that we're the only humans. Not literally, our machines and cities produce more noise than ever existed in prehistory, but cognitively quieter, with only one type of human consciousness generating meaning, asking questions, creating explanations. Imagine the richness of a world where different human species had different languages, not just different words for the same concepts, but fundamentally different ways of structuring thought. Languages that emerged from different brains, different vocal anatomies, different cognitive architectures. Neanderthal language, if it existed, might have been more tonal, more musical, given their different vocal tract anatomy, or perhaps more gestural, supplementing sound with movement in ways we've lost. Their larger occipital lobes might have given them a more visual language, with concepts we can't express because we don't see the world the way they did. The Denisovans, adapted to high altitudes where sound carries differently, might have developed unique acoustic properties in their language. Whistling languages, like those still used in some mountainous regions today, might echo ancient Denisovan communication strategies. The hobbits of Flores, with their smaller brains, might have had a simpler but more efficient language, stripped of unnecessary abstraction, focused on immediate practical communication. Or perhaps, like some birds with tiny brains who produce complex songs, they had rich linguistic abilities that defied their cranial capacity. All these potential languages, these different ways of encoding and sharing experience, are gone. We're left with just human languages, diverse, yes, but all emerging from the same cognitive template, all constrained by the same brain architecture, all expressing the same basic type of consciousness. After we became the only humans, something remarkable happened to our population growth. For most of our species' existence, there were fewer than 1 million humans on Earth. As recently as 10,000 years ago, there were perhaps 5 million of us globally. Today, we number nearly 8 billion. This explosive growth only became possible after our cousin species went extinct. While they existed, we were constrained, competing for resources, limited to certain environments. Their extinction opened up entire continents for our expansion, but it wasn't just physical space that opened up. Cognitive space expanded too. Without other human species to challenge our worldview, we were free to create grand narratives about human superiority, about our divine mandate to rule the earth, about progress and destiny, and manifest fate. These stories, impossible to maintain if other human species still existed, fueled our expansion. They justified our transformation of the planet, our domination of other species, our consumption of resources. They made us feel unique, chosen, special in ways that would have seemed absurd if Neanderthals still walked among us. The agricultural revolution, which began shortly after we became the only humans, might not be coincidental. Agriculture requires a particular worldview, that humans are separate from and superior to nature, that we have the right to transform landscapes, that our needs supersede those of other species. This worldview is easier to maintain when there are no other human species to remind us that we're just one experiment among many. Throughout our history, as the only humans, we've been obsessed with creating mirrors, artificial others that reflect our humanity back to us. We've anthropomorphized animals, projecting human consciousness onto species that experience the world in fundamentally different ways. We've created gods in our image, imagining divine beings that think and feel like humans, but with superhuman powers. We've invented angels and demons, aliens and robots, all essentially human minds in different bodies. This obsession with creating others might stem from the loneliness of being the only humans. We're desperate for confirmation that consciousness like ours could exist in different forms. Every story about talking animals, every myth about gods walking among humans, every science fiction tale about alien contact might be an attempt to fill the void left by our extinct cousins. Now we're on the verge of creating artificial intelligence that might actually be conscious. If we succeed, we'll no longer be alone. But the AI we create will be our children, shaped by our assumptions, trained on our data, reflecting our biases. They won't be the independent other that our cousin species were. They'll be mirrors of ourselves, perhaps distorted, perhaps improved, but fundamentally emerging from human consciousness, rather than representing an alternative to it. Ecologically, being the only human species has had profound consequences. Ecosystems evolved with multiple human predators, multiple human impacts. The sudden reduction to a single human species might have been as ecologically disruptive as the arrival of humans in previously human-free environments. Consider that different human species likely had different hunting strategies, different prey preferences, different impacts on plant communities. Neanderthals, with their strength and cold adaptations, might have focused on different animals than Homo sapiens. The hobbits of Flores, being small, would have had different caloric needs and hunting capabilities. The extinction of other human species didn't just remove competitors, it removed entire ecological roles. Predator-prey relationships that had evolved over hundreds of thousands of years suddenly ended. Plant species that might have been dispersed by one human species but not another lost their dispersal mechanism. This ecological simplification from multiple human impacts to just one might have contributed to the megafaunal extinctions that followed. Ecosystems that had adapted to pressure from multiple human species suddenly faced pressure from just one, but that one was more numerous, more widespread, and more technologically advanced than any single species had been before. Let's imagine for a moment how different our world might be if other human species had survived. Perhaps Neanderthals would have remained in Europe, their cold adaptations giving them an advantage during the ice ages. Maybe they would have developed their own civilizations, their conservative nature leading to stable, sustainable societies that changed slowly but lasted millennia. Maybe Denisovans would have become the mountain people, inhabiting the high places from Tibet to the Andes, developing unique technologies for high-altitude living. Their cities might have been built at elevations where Homo sapiens struggled to breathe, creating natural boundaries between our territories. The hobbits of Flores and other island species might have remained isolated, developing their own unique cultures on islands around the world. Each island might have had its own human species, its own evolutionary experiment, its own solution to consciousness. In this alternate history, the concept of humanity would be radically different. We couldn't claim to be made in God's image if God's image came in multiple forms. We couldn't justify exploitation based on minor racial differences when major species differences existed. We would have been forced to develop more nuanced concepts of consciousness, intelligence, and worth. International relations would be interspecies relations. Wars might have been fought, not between nations, but between species. Or perhaps the obvious biological differences would have made cooperation more necessary, each species recognizing its unique adaptations and seeking complementary relationships rather than competition. Science would be richer, with different human species potentially having different cognitive strengths. Perhaps Neanderthals would have excelled at certain types of thinking that we struggle with. Perhaps Denisovans would have perceived patterns we miss. Each species would have contributed its unique perspective to our understanding of the universe. But this future never came to pass. We remain alone, the sole inheritors of human consciousness, carrying within us faint genetic echoes of what might have been. Being the last human species carries a unique moral weight. We're not just responsible for our own survival, but for the continuation of the entire human experiment. Every decision we make about climate change, about nuclear weapons, about artificial intelligence, about genetic engineering, is made with no backup. If we fail, there's no other human species to carry on. The torch of human consciousness will be extinguished forever. This responsibility extends beyond our own survival to the preservation of consciousness itself. If we're the only conscious beings in the universe, and we might be, then we have a cosmic responsibility to ensure consciousness continues in some form. This might mean spreading Earth life to other planets, ensuring that even if Earth becomes uninhabitable, life and consciousness continue elsewhere. It might mean creating artificial consciousness that can survive in environments where biological life cannot. It might mean modifying ourselves to survive changed conditions rather than trying to preserve conditions suitable for current humans. But it definitely means recognizing the preciousness of what we carry. We're not just individuals living our lives. We're links in a chain of consciousness that stretches back hundreds of thousands of years and might stretch forward for billions more. Every human death is the extinction of a unique form of consciousness. Every human birth is a new experiment in awareness. It's a story of triumph and tragedy, of survival and loss, of achieving ultimate evolutionary success while losing the diversity that makes success meaningful. We stand alone now on this planet, the last of our kind, surrounded by the ghosts of extinct cousins in the ruins of ecosystems we've transformed. We search the skies for other intelligence while destroying the intelligence that surrounds us in other species. We mourn our loneliness while causing the very extinctions that deepen it. But we also stand at a unique moment in the history of life on Earth. We're the first species that understands evolution, that can read the history written in DNA, that can consciously choose our own future evolution. We're the first species that might spread life beyond Earth, ensuring its survival even if our planet becomes uninhabitable. As you lie there in the darkness, preparing for sleep, remember that you are extraordinary, not because you're human, but because you're the last human. You carry within you the genetic legacy of multiple human species, the cultural inheritance of thousands of generations, the responsibility of being possibly the only conscious observer in the universe. Your dreams tonight will be the dreams of the last hominid. No Neanderthal will dream alongside you. No Denisovan will share your visions. No hobbit will tell stories under the same stars. You dream alone for all humanity, for all the human species that were and might have been. But in that loneliness is a strange kind of connection. Every human alive shares this unique position with you. We're all the last humans together, bound by our singular status, united in our isolation. We may be the only human species, but we're not truly alone. We have each other, 8 billion variations on the theme of Homo sapiens, each carrying unique combinations of ancient genes and modern dreams. Tomorrow, when you wake, you'll continue the story that your extinct cousins cannot. You'll think thoughts that Neanderthals never could, solve problems Denisovans never faced, create art the hobbits never imagined. You'll carry forward the human experiment, the only version of it left. Sweet dreams, last hominid. May your sleep be peaceful, your dreams be rich, and your awakening be to a world where being the only human species becomes not a source of loneliness, but of responsibility, not of superiority, but of humility, not of isolation, but of connection to all life on Earth. For in the end, being the last human means being the guardian of consciousness itself, the keeper of the flame that allows the universe to know itself. It's a heavy burden, but also an incredible privilege. You are the universe, looking at itself, the cosmos becoming conscious, matter achieving the ability to matter. Sleep now, carrying with you the genes of the extinct, the dreams of the lost, and the hope of the future. You are Homo sapiens, the wise human, the last human, the only human. And that makes you infinitely precious.